And lastly, let's take a look at this patient. Here we have a severe crowding over here. It's definitely an extraction case. So I extracted the first bicuspid, and once again, I didn't put continuous arch wire. Wire was cut here. Okay. To resolve this major discrepancy, lead to a simulation. What I do was I designed the force system first. I want labial force on the lateral, without any moment. The rotation is good, so I don't need any rotation control. I need a labial force. And on the cuspid, as it cannot exist alone, there should be a distal force, which is on the cuspid. So distal force is acting at the cuspid. However, this distal force is acting at the buccal side of the single resistance. It is going not only tips distally, but it's going to rotate in clockwise direction. So what I need is to have is this possible when I'm asking this? It's not possible. Even though the force is summed to zero, there is an equal and opposite force which produces couple, so that there should be a counterclockwise couple to cancel it. So this is not possible. So where would I put the counterclockwise moment to satisfy Newton's first law? Not here, because it is going to rotate this way. So I put this kind of rotation here, so that I put distal force and counterclockwise moment, and my question is this consistent? Yes, it is consistent. Both force and the counterclockwise moment on the bracket is consistent for this patient. So this is a valid force diagram that I make before our treatment. Then next step is to design the force system to prove it's this force system. So this is the force system required. Okay. So first step is to make a wire passive all the time. So the wire was made passively. Virtually, and we're doing a thought experiment. Now, next step is simulation. So what I do is to simulate this wire buccally. So it's going to deflect somewhat like this. Okay. And the shape, this is a simulated shape. And it's a little bit wiggle, but it looks like a straight wire, right? So rather than bending a wire here like this, I'd rather use a small piece of a straight wire instead. So what I do was, this is the permanent bend that I make. This is the correct shape. But rather than wire with the little bends over here, I would rather use a straight wire here. Okay, so if I put the activation force, it's going to put it in here without any moment, so that this is a force system produced by the appliance that we designed. Okay, so here is a segment of the wire here. I engaged into the cuspid first, okay, and I activated it. And you can see that the wire is over this bracket, and if you carefully look at it, wire is not inserted into the slot. Why it is not inserted into the slot? That's because it's to produce class 4 force system. That means cantilever force system. So you can use the button instead of the bracket. But if you put the bracket, then the wires should be placed over it, but be careful not to insert it into the slot. So then you slowly lightly with the ligature wire. This is the force system that we designed and the force system that produced by this segmental wire. And let's see if it really goes like this. It's 2 months later, 3 months later, and it's fully deactivated. So you can see that only these 2 wires engaged, and all the force systems are consistent. And now it's time to apply continuous arch wire for further. So here's the patient before and after. If you were using a continuous arch wire to begin with, you will definitely have an open bite on the left side.